Welcome to the Cincinnati AI Builders. Our agenda today is we're going to talk about the mission. Then we'll have our featured presentation with Jeff. And then we'll do a round of room at about 5 till 7 if we have time, or we can do more Q&A with Jeff, whatever everybody wants. And then we'll end. All right. So the mission is to enhance the skills and productivity of the builders of the AI-enabled systems and solutions in the Cincinnati region. So we're a group that has AI professionals in it, AI novice, AI curious, AI, whatever it is. But we're more focused on the technical side than we are on the business side. The one thing to remember is that this is a public meeting. This video will be posted on YouTube and transcript will be made public. So if you've got any proprietary IP that you don't want shared to the rest of the world, this is not the meeting for you. Just a quick update, a group update. We now have a website. It routes to our LinkedIn page. So if you're not part of the LinkedIn page, go to this website and click to become a member. And we have an info email, info@CinciBuilders, CinciAIBuilders.com. All right. Now we're going to slide right into our presentation. So today, Jeff Gunderson is going to be talking about LLM solutions for text classifications. And Jeff, I'm not going to read this whole thing. If you want to go ahead and share, you should be able to grab the screen.
Yeah, sounds good. Good evening, everyone. It's very impressive backgrounds. I'd love to talk to each of you individually. Thank you, Joe. Thank you for introducing me and for organizing this meeting. A little bit of background on myself. So I'm currently the team lead for Delta Analytics. Delta Analytics manages data for good fellowships for nonprofits, mainly in analytics and data science. What we do is we provide a team of volunteer data analysts and data scientists, and we help a nonprofit manage a project. Typically, a project will be like 4 or 5 months, and we'll try and do maybe 5 projects a year if we can, depending upon the volunteers that we're able to get. But I help them manage projects. I also help them review the applications from the nonprofits, and I also help them recruit the volunteers also, the volunteer data scientists. Another thing, a little bit more background. I don't know if I give you some more background on myself. Before that, I was the enterprise data architect for St. Elizabeth. Before that, I had a BI software product that I developed and sold, partnering with some other companies. And before that, I had quite a few years in software engineering. So I worked for Syncom Systems as a software engineering manager. I don't know if any of you have heard of Syncom Systems. They were a big software company in Cincinnati years ago. Oh, another thing too, I'm also working on a book about AI and social determinants of health. And I put a link to a website there. I'm posting some of the materials for the book at that website, socialhealthai.org. One of the projects that we did last year for a nonprofit is the basis for most of the work I'm going to be showing you. We worked with a nonprofit that helped youth by providing an application that supported group chats. And they wanted to see if the chats could be used to determine the well-being of the youth. Particularly, they wanted to know, did the well-being improve after they joined the organization? And they also wanted to know which youth might be in distress, so which youth might need help. So I'm also showing you some of the constraints they had on the project. These are typical of nonprofits because they don't have a lot of resources. So some of the constraints are that they wanted it to be a low-cost solution. They wanted it to be something they could implement locally also. They were very concerned about the security of the data. So it's important to them to be able to implement this locally. They wanted to use open source if possible and use free services whenever possible. So that's the project we worked on. The problem with that project is the data is sensitive. So I couldn't use it for examples to show people, like example notebooks, and let them be able to actually use the data. So what I did was I changed the data to use a different data set. There's a data set called Dreadit, which is a public data set, which has labeled data for stress from social media. So what they did is they took about 200,000 posts from different Reddit communities, and they labeled them to determine the stress. So by using this, I can then provide examples which are public and people can use public data. So I did use the constraints from the well-being project, the constraints about using open source and being able to implement this as a local model. And by the way, too, if you have questions during this, just raise your hand. And Joe, if you see a hand raised, just let me know because I probably won't be able to see it.
Yeah, I'm your timekeeper and your question again, guys. So
Awesome.
get back to-
Awesome. Okay. Sounds good. So here's some of the examples, the dreaded examples. So this is public data and it's de-identified. But if you were actually going to be implementing an application about mental health, there would be ethical considerations. You would want to protect the data. You would want to consider problems, maybe with false positives. You would want to consider the impact of interventions. You would also want to make sure that the data isn't biased. So I'm not really going to cover these things, that this is public data. So just a little bit of background on natural language processing for classification. There's a number of options for doing this. A lot of the early solutions use statistical methods and machine learning methods like decision trees, but these usually involved manual feature engineering. Like you would have to look at the messages and count the number of certain kinds of words or count the number of certain kinds of phrases. So there was a lot of human effort involved in a lot of those implementations using machine learning. Later on, deep learning improved this a lot by not just considering the words, but also considering the sequences of words. Deep learning lets you look at the sequence through recurrent neural networks or long short-term memory models, not just the words, but the sequences themselves. But now LLM transformers are really the state of the art. And for this project, we use transformers. So the organization that we worked with, they had used decision trees to try and classify their messages, but we thought we could do much better with transformers. They didn't get very good results with decision trees. So I'll be showing you results based on transformers, and I'll use the constraints that I showed. We're using a small, medium-sized open source model that we can implement locally. So the first thing I want to show you is encoder transformers. So encoder transformers are used to extract some kind of meaningful representation from the input text when they are trained both on the past and the future tokens. So it looks at the previous tokens in a message and then the future tokens, the remaining tokens in the message in both directions. They're nice because they're relatively small and they're fast, and you can run them on a lot of platforms. They've been trained on a corpus of data, but they're small enough so that if you train them, you can actually adjust their weights. So they're not so big that when you fine tune them or train them, you can't adjust their weights. So the really popular ones are called the BERTs. The BERT stands for bidirectional encoder representations from transformers.
Yeah.
So those are, and I tried so hard to find an image of BERT that wasn't copyrighted, and this one's not copyrighted because it's not actually BERT. So to do this, I'm not going to go through the actual code for these. I'm just going to give you an overview of what the code does. But if you want to use the actual code and run these yourselves, I will provide a GitHub repository at the end of this talk, so you can actually look at these examples and run them yourself. The examples also, you should note, use the Hugging Face libraries. So a lot of what I'm saying is particular to the Hugging Face libraries. When I tested these, I did them probably in 3 different ways. I used my machine. I also ran some of these on Kaggle and some of these on Google Colab. So if you don't have sufficient GPU power, you can run these on Kaggle, and you'll be able to use Kaggle for free.
Also, just another thing is Hugging Face does provide a free inference engine API, so you can specify a model, even one of your own making, and run it through their API for nothing, for as long as you don't abuse it.
Yeah, awesome. Thanks, Steve. Yeah, I mean, Google Colab is good also. Kaggle, I've had the best luck with Kaggle though. Google Colab gets very busy. So to fine tune BERT, first you need, like always, you need to pre-process your data. And for this example, really, I just needed to tokenize the input, change the input into numeric vectors. The next thing you need to do is load the model. And when you load the model using Hugging Face, you can specify the number of labels to use for classification. And what this does is it creates a linear layer on top of BERT to output the classifications. So it just provides a simple linear layer with two different nodes that allows you to classify your labels. I then run training using the using a training and validation data set. And this adjusts BERT's pre-trained weights and also the classification layer. I then run inferences on test data and then print the classification report. So a nice thing about the BERTs is they're pretty easy to use. There's not a lot of code that you have to worry about when you're writing a notebook or a script to use BERT. One of the things I use to evaluate the performance of the models is classification metrics. And just a little bit, I didn't use all of the classification metrics, just a few to keep it simple. But the metrics that provide precision, recall, and F1 score are very useful. So precision is on the average, when a model predicts a class, how often is it correct? And then for recall, on the average, how well does the model capture all of the instances of a class or each class? And then what the F1 score does is try to ensure that both precision and recall are balanced across all classes. So it gives you an idea of how it's predicting and how well it's capturing all of the classes. So when I run the dreaded data through BERT, here's the results that I'm getting. And what I'm showing you the size of the model, how many parameters are in the model, the classification metrics, the memory requirements for RAM and GPU, and also showing you how long it takes you to train and how long it takes you to run the inferences. So the inferences, it took 1 second for inferences. And what I'm doing is I'm running, it's 200 inferences. So I'm asking it to make 200 predictions and it does that in 1 second. And inferences is like taking a message and coming up with the classification for it, the prediction. So you can see it's doing okay. 75% is okay, not great. Could be a useful model, but we could probably do better than this. So one of the things you can do is you can run a larger version of BERT with 355 million parameters. And I was hoping this would give me a lot better results. And it did give me better results, a bit better, but it is starting to slow down. It's taking maybe 4 times long to do the training, 4 times long to do the inference, but getting a little bit better results. The nice thing about the BERTs is they have domain-specific versions. So they have models which have been trained on domain-specific data, BERTs that are trained on biomedical data, financial data, legal, security data, social media data, software engineering data, and multilingual data. So they're domain-specific BERTs, and they're very nice because they're small. They're not like the large Roberta model. And if you have a classification problem and you're using a BERT, this is probably a really good thing to look at. Start searching on the domain-specific BERTs to see if there's something that might be in the area that you're working on.
So for what you're doing, if you go back one slide, for what you're doing in your example, the conversational social media BERT probably was the best model for that, right? Because you're trying to gauge the overall indication or what the overall intent of the text was, right?
Yeah, and you know what? It may be the best BERT model, but you know what? I did find another one in healthcare. So I do intend on trying the social media BERTs, but I found one in healthcare, which gave me some pretty good results. So there's a model called Mental BERT, which was trained on mental health care data. And I thought that would be a really good fit for trying to classify stress, because stress is probably a very common discussion item for mental health care. So that did give me pretty better results. Now I'm at 80. I like to see models when they get to 80 in the area of recall and precision. So it is doing better. And the training time and the inference time is not larger I had with the Roberta model. So it is getting better. So these are the BERT models, but there's another thing you can do with transformers. I showed you the encoder transformer, but you can also use a decoder transformer. So decoders are not really trying to find a representation of the input text, but they're trying to generate the next token in a sequence. And you're familiar with those like ChatGPT. So although they're trying to generate the next token in a sequence, there are ways you can constrain them to just output a class. And the nice thing about the decoders is there's some much larger models that were trained on larger sets of data that are open source. And so you can probably find models that have a lot more training than the BERT models and may understand the context better when you're trying to classify text data. To fine tune the decoder transformer, you need to preprocess the data. You need to load the model. Now, the models that I'm using are fairly big and they wouldn't fit on some of the free platforms like Kaggle or My Machine or Google Colab. So what I did is I used what's called quantization to reduce the size. And what that does is it reduces the precision of the weights. So I think the normal weight precision is like a 32-bit number. And I'm saying, okay, reduce the precision to a 4-bit number. And that way you can load some pretty good sized models. And when you load the model, you can specify the number of labels. And this creates a layer on top of the model for classification, just like we did for BERT. The models I'm using are pretty big and you really can't train all the weights in them because they're too big. So what you can do is use a tool called LLM, which stands for low rank adaptation. And what that does is it adds layers alongside the model layers for training. So you're not really training the layers in the model itself. You're training these additional layers that are added alongside the model. It's actually a little more complex than I described. It actually creates two matrices and it does a product of them, and then it adds them to the weights. It's a little bit complicated. The gist of it is it's adding some layers to train. Then you train the data using your training and validation data set. And what this does is it adjusts the LoRa layers, and it also adjusts the classification layer. And then again, you run the inferences on the test data and you print the classification report. So what I did is I did the test with Llama, and that has quite a few more parameters than the BERT models do. And it's giving me a little bit better results. The performance is taking quite a hit. It's using a lot of GPU memory. The training is taking a long time. The inference is taking a long time too. Probably couldn't use this for a real-time kind of thing because it's taking too long for the inference. But it did get a little bit better. So one of the things you can do is maybe look at other models. And during the original project, we tested many models to try to find the best model. So one of the models that I found that did a really good job was 5.3 from Microsoft. So 5.3 has optimizations for classifications, and it was trained on text that's more aligned for classifications also. So it has some advantages over some of the other models, which are more generalized. And it also, 5.3 also has more context. So it has a bigger context window. So that means it can look at more of the context and consider more of the tokens in the entire context than a model with smaller context windows. So you can see it's getting better. It's up to 83 now. And the performance is at least it's smaller than Llama. I think if I kept going with this and I kept trying models, I could maybe do better. It's getting pretty good. What I've been showing you is fine-tuning models, but if you didn't have labels, you could also use another technique. You could also use a prompt to classify your data. So what you would do is you would create a prompt that describes the task, the classification task, and then you would provide the messages that you want to classify in the prompt. So if that's the way you did it, if you just described it and provided the messages, that's usually called a zero-shot prompting. Now, prompt really needs to also constrain the output for classifications. So when you give a decoder a task, sometimes it gets pretty chatty and provides things you didn't ask for. So one of the things you need to work on is making sure that it constrains the output just to the classifications that you want. When you run the model, there are ways that you can specify that you want deterministic output. Also, when you're using a particular model, you can look at the prompt guidelines for that model. If you're using models from Hugging Face, you can go to Hugging Face and review what the model authors documented for the prompt guidelines. But overall, prompt engineering is very important. And that you could do a whole session on that. And I think, you know what? I think there was a session in this group on that, on prompt engineering. I don't know if anyone attended that. I think it was last year.
That was me.
Oh,
Yeah.
excellent. Excellent. I wish I could have attended. So you can vouch for that. Prompt engineering is everything. Making sure your prompt is consistent, uses a consistent format, consistent terminology, make sure it doesn't give too much information which is not necessary. Also try to keep it the size down if possible. In general, the more context you give it, the more confused it tends to get.
Iteration has always been my favorite thing to point out, is that you start small.
Right.
And then you just build a little bit and a little bit. And then I guess it's just like training a model, right? You'll keep going and going. Then all of a sudden you'll see that you're overtraining and you just back off a little bit and it'll get the data as close as it can.
Yeah, it's something you can spend quite a bit of time on.
You have something, Steve?
Yeah.
You want to add?
Another trick for that is you can use something called structured output, assuming the model knows what that is. And you can define constraint around in the structured output, like it has to conform to this structure or this class or this. And in your case, you would use something called an enum, where you say, these are the 5 values that you can come back with, and it has to be one of these 5. But that's another trick. That's a newer thing.
Yeah, I didn't get a chance to look at that very much. I started looking at that, but I think isn't that particular to certain models?
Yeah, you have to have a model that supports it.
Yeah, but that's a good point. I'm going to look at that some more. So if we do a prompt, we're going to need to define stress. What I did is I looked at the stress description that was given to the labelers with the Dreaded data set. So I started with that, but I also did some other descriptions of stress based on studies of stress. So I found a couple studies that are regarded as pretty good authorities on stress and use those definitions. So here's an example of what the prompt looks like. And this is the prompt based on the Dreaded labeling. So you can see that this is a classification task. So I'm saying that explicitly. And I use the word class throughout the prompt consistently. I've got a really simple description. I'm giving it 2 messages to classify, and I tell it I'm giving it 2 messages. And I also tell it how to format the output. One more note too, I find that separating things with space with blank lines helps quite a bit, especially lists. If you give it lists of things, separating it with blank lines is really good. So to generate the classifications, what you need to do is load the model, keeping it small with 4-bit quantization. Construct your prompt, adding the messages to it. You may need to do this multiple times if you have many messages and you're only handling a few messages in each prompt. So you may need to put this in a loop to generate many prompts. You then do the generation using deterministic settings. But the biggest setting that you want to be concerned about is the setting that lets you generate the highest probability token instead of less deterministic settings, which can favor the other tokens, which aren't the highest probability. You then need to parse the output to get your classifications, and then you can run a classification report. So here's how the 3 different stress definitions did. And I used the 5-3 model for these. And you can see they're not doing so well. We got the recall in mid 70s in a couple of cases, in the 60s in one case. If you looked at these, probably the best would be the Dreaded. And that kind of makes sense because the Dreaded was based on the definition that the labelers were given when they labeled the data. But we're not doing real good. So another thing, we could try what's called a few-shot prompting. So in few-shot prompting, instead of describing the task, You depend less on descriptions of the task, but you depend more on giving it examples. I was saying I didn't have labeled data, but in this case, I'm willing to label a few things for it. I'm giving it 4 examples and asking it based on these 4 examples to please classify the stress. And again, I'm using the same kind of format I used before for the messages. So in this case, the few shot is probably doing as well as the dreaded did. Not too good, but probably as well as that's doing. And that makes sense because it's based on some examples from the actual data, from the labeled data. I was wondering, why isn't the model doing well with the prompts? And one of my theories was, what we're doing is we're comparing the classifications that we're getting to the labels in the data set. But the models really don't have a lot to go on. They just have a description in one case, or they have a few examples in another case. So I think what the models are really doing is they're relying on their training, particularly their training on the word stress. So that's what really they're making progress with, is just their understanding of stress from their training. So if we use a larger model with a lot more parameters and a lot more training, would we get better results? So one of the things I did is I tried this with ChatGPT, and yeah, we do get better results, much better results when we use a very large model. But the problem is I can't really use these results with this project because ChatGPT it's not really a model I can use locally. If I used other models, maybe like DeepSeek, I can maybe even get better results.
How does this differ from sentiment analysis?
So this is very similar to sentiment analysis, but and it's really the general case is classification, but sentiment analysis, you're just classifying into 2 cases, either good or bad. But it's not the same as good or bad because it's stressed or not stressed. So in that case, I'm not sure you would really want to call it sentiment analysis. And in the well-being case, we had 5 classes. So that was very challenging because it is quite a bit more challenging to take a natural language and classify it into 5 different levels. That's very challenging. 2 or 3 levels is not so bad. 5 levels is pretty challenging. Thanks for your attention on this. And I'm hoping this gives some ideas on solutions you can use for classification. Here's the GitHub site if you'd like to see the examples. And if you're at all interested in getting involved with data science for good, you could visit Delta Analytics. Also, while I'm talking about that, also, if you know of nonprofits in the Cincinnati area that need help with data science projects, let me know, or maybe even help with data analytics projects. Also, if you're at all interested in AI and social determinants of health, please visit the socialhealthai.org site.
Outstanding, Jeff. Thank you so very much for everything you do. This is a really outstanding presentation.
Oh, thank you.
I will post all of these when I post it on YouTube. I'll make sure that I post all of these sites that you have, and I'll try to promote you as much as I can. Jeff put together a nice presentation for it being very last moment. So thank you so much.
Yeah. And I'm going to be presenting this at a Delta Analytics hackathon also. So I was really motivated to get this done. So yeah, thank you for the opportunity. Thank you so much. And thank you for your attention on this.
I think we all benefited from it. I got a few more slides to get into, and if people want to hang out, I'm more than happy to do that. We're always looking for presenters, and you can contact me at joe@cincinnatiaibuilders.com if you have an idea or something. So I'm trying to get us scheduled a little more far in advance. 2025 is really going to be the year for this group. I'm working very closely with Carl. We're working together to try to build this in bigger numbers and try to get some good speakers in here and try and have a little more organization. Our next meeting is April 15th, which is tax day. You can come and forget about your tax problems and join us here. Jeff, with that, I will open it up to the floor. I want to contact you about some of the volunteer stuff you're doing. The health thing that you're involved in, can you explain that a little bit more about what that is and what you're doing there?
Oh, about the social health AI site.
Yeah.
Yeah. So yes, I'm starting to write a book on AI and social determinants of health. And yet I'm posting a lot of articles and material on that site, the Social Health AI site, but it forces me to write and stay organized if I publish articles there. But what it is, it's a lot of information that helps you understand the kinds of data that's important for social factors involving health. What kinds of AI can be very helpful for determining social factors and determining social factors that affect health. And I'm using a lot of the information from our Delta Analytics projects for this, because many of the projects we're involved in involve these kinds of social factors and involve these kinds of health factors. For instance, the health of youth and the social factors that affect the health of youth, or the social factors that affect the mental health of youth. So a lot of the projects that I'm working on give me some really good background for this project.
I was going to say, can you give an example of something that an output, a deliverable that you've done or hope to do? What it's just an example of what your determinations are.
Oh, sure. One of the projects, for instance, we worked with an organization that they help teams in Central America, and they work through school systems that help the teams, and they provide a social app where the teams can communicate with social workers or with each other or with teachers or with doctors in some cases. So they provide this kind of social application framework for the teens. And the organization wanted us to predict some really high risk problems for the teens: diabetes, obesity, also some mental health issues, and suicidality is another one. So a lot of the work we did was develop models that could take that social help or social media information and make predictions on which teens are at high risk for these things. And then what they do is they use that information to alert the social workers or alert people that are involved with the teens and take some kind of intervention or make recommendations on classes they should take or other teens they should network with or make recommendations on social workers they should network with.
Excellent. Anybody else have any questions for Jeff?
No, I thought it was good.
Thanks, Steve. I'm going to thank everybody for attending. And with that, I'll say good night to everybody, and we'll see you hopefully on the 15th. If you have any questions, don't hesitate to reach out to me. Bye, everybody. Good night.